Let's talk about paper chromatography. Paper chromatography is a common technique widely used for the separation of chlorophyll pigments, amino acids, DNA bases, and etc. In paper chromatography, paper acts as a solid supporting material, while the water molecules present in the pores of the paper acts as a stationary phase. While the mixture of different solvents such as ethanol, ether, etc. can be used as a mobile phase. Now, the sample is applied on the paper using a capillary, where the process of a liquid flowing in a narrow space without the assistance of external forces like gravity. Once the sample is applied, the chromatography can be carried out in different mode. The mode of operation of paper chromatography can be ascending mode, descending mode, radial mode, and two-dimensional mode. Let us first start in the ascending mode. Ascending mode, the mobile phase solvent is capped at the bottom of the chamber. A small portion of paper is immersed in the mobile phase. The solvent in the mobile phase moves upwards due to the capillary reaction. During this process, the sample molecules get separated. Separation occurs because of the difference in the solubility of molecules in the mobile phase and the stationary phase. In the descending mode, the mobile phase solvent is kept on the top of the chamber. The solvent in the mobile phase moves downwards and separates the sample molecules. It indicates that the solvent reservoir is at the top. Now, in the case of radio paper chromatography, a wick is attached at the center of a circular paper. This wick remains submerged in the mobile phase. The wick absorbs the mobile phase solvent by capillary action. As the mobile phase moves throughout the paper in a radial fashion, the separation of the sample occurs radially. Next is in the case of two-dimensional paper chromatography, the chromatography is first carried out in one dimension. Once the chromatogram is over, the paper is now rotated by 90 degrees and the chromatogram is again carried out. Lastly, the 2D chromatography is widely used to separate amino acids due to its ability to effectively resolve complex mixtures by utilizing two different stationary phases and separation techniques.
Okay, now for our materials. What we need is some filter paper. I took this large piece of circular filter paper and cut it into strips so that it could fit inside our beakers nicely. Okay, so we have filter paper. We have beakers. We have the solvents of acetone, which is the chemical name for nail polish remover. We have isopropyl alcohol, which is the chemical name for rubbing alcohol. And deionized or distilled water, which is pure water, not the same stuff as from our tap from our sink. And then we have a ruler, a pencil to mark where everything started and stopped, because pencils are not soluble in any of these. And then some ink in order to test. So I chose the color black because I like to see the differences in the black pigments. And as always, you need some goggles because even these solvents are going to possibly hurt your eyes if they're splashed in there.
This technique allows us to separate the different components of a mixture. For this experiment, we will use a TLC plate, a sample, and a solvent. The TLC plate has two sides. Be sure to use the rough side, which is coated in silica for the experiment.
Using a pencil and ruler, draw a line 1 centimeter from the bottom of the plate, then another line 5 centimeters above the first line. These lines indicate your start and finish. Draw the lines lightly to avoid scratching the silica off of the plate. Next, make a small tick mark in the center of the start line. You will need a tick mark for each sample. Using a microcapillary tube, load the sample onto the TLC plate. To load the sample into the microcapillary tube, simply touch it to the surface of the sample. You will see the sample travel up the inside of the tube due to capillary action.
Press the tip of the tube briefly to the TLC plate on the tick mark at the start line. Repeat this process until you have a concentrated point of sample. Keep the sample spot as small as possible in order to maximize your resolution. Multiple brief touches with the microcapillary tube are best. To prepare the TLC chamber, add 5 milliliters of solvent. We usually use a 7:3 mixture of hexane and acetone. Cap the chamber for several minutes and allow the gases to reach equilibrium.
Use forceps to place the TLC plate into the developing chamber. Cap the chamber immediately. Once the solvent line reaches the top line, remove the plate and set it on the bench top to dry. Note, if your sample is not colored, you will have to use a UV lamp to observe the spots.
Chromatography may be a noteworthy partition strategy utilized in numerous logical areas, counting chemistry, science, and forensics. It encourages the partition and distinguishing proof of components in blends by taking advantage of contrast in their development through a stationary stage that's influenced by a versatile stage. The viability of chromatography depends on angles, such as the characteristics of the stationary and portable stages, the polarities of the substances included, and the intelligence between the atoms. Different sorts of chromatography, counting paper, thin layer, gas, and fluid chromatography address particular expository prerequisites. In conclusion, chromatography serves as a fundamental expository apparatus that gives both subjective and quantitative data approximately blends. It is broadly utilized in research, quality control, and restorative determination, highlighting its centrality within the progression of logical understanding.
Give a brief introduction to spectroscopy. We know that electromagnetic radiations carry energy in waves. So when these energy-carrying waves strike any material particle, they produce some change in the particle. The study of the effects of interaction between electromagnetic radiation and matter is called spectroscopy. Thus, spectroscopy is the study of interaction of electromagnetic radiation with matter. There are two ways in which the interaction between electromagnetic radiation and matter can take place: by absorption and by emission. Let's first discuss about absorption. When the electrons present in atoms or molecules of the matter absorb energy from electromagnetic radiation falling on it, they jump from ground state to excited state. This phenomenon is called absorption. Now let's discuss about emission. When the atoms or molecules present in the matter jump from excited state to the ground state, they release electromagnetic radiation. This is called emission. Spectroscopy is extensively used to study the internal structure of matter, especially molecules of complex organic or inorganic compounds. Some of the major advantages of using spectroscopy over trivial methods of structural determination of complex compounds are: it is a very less time-consuming. The amount of sample required is very less. Although the setup cost of spectroscopy is high, but it's very cost-effective in long run. Note that in both absorption and emission, the energy of electromagnetic radiation absorbed or released is equal to the difference between the energy of the excited and ground states. The related terms are
In order to construct your simple device, you will need a piece of cardboard, a toilet paper core, a DVD or a CD disc, black masking tape, and sellotape. You will also need a couple of tools like a ruler, a pair of scissors, a paper cutting knife, and finally a pencil.
To start off, we're going to cut a line in the paper towel tube that has about a 45-degree angle. I was able to do it with scissors, but an X-Acto knife would probably make this easier. This will definitely be something that parents should help with. As you can see, I kind of made the angled cut a little far in, so I'll insert a clip right here showing the right distance you should have around the tube. On the other side of the slit, cut a small square to look into the paper towel tube. As a side note, you can totally use markers or paint to decorate your tube. Next, you're going to trace a circle out of cardstock and cut it out. You're also going to cut out a rectangle in the middle of the circle to let light through. Then tape this circle to the top of your spectroscope. Finally, put the CD in, blank side up, and go out into the sunlight to check out the rainbows you can see.
The one on the left is my LCD monitor I use for work, while the one on the right is a white LED lamp on my ceiling in a cool white setting. Since the LED lamp setting can be changed from cool to warm, I recorded this change in real time for you as well. You can clearly see how the spectrum changes between the warm and cool settings, gaining intensity at the blue end. I have also recorded the spectrum of a color LED lamp, starting with white and yellow-white light. Can you see how different the ceiling LED lamp is from this small lamp, despite both delivering seemingly white light? I then cycle through all available colors in the lamp, starting with red, blue and green, and mixtures of the three, for you to see how an LED lamp creates a continuous color circle using its three components only. And finally, I saved the best for last. Can you guess what source you're looking at with all these beautiful emission lines? You can now pause the video for a moment to have a think before I reveal the answer. It is a high-pressure sodium lamp I observed in my street. Depending on where you live, you might not be able to see this spectrum if the sodium lamps were exchanged for a more energy-saving option of LED lamps.
In conclusion, spectroscopy is a powerful scientific method used to study the interaction between light and matter. It helps identify substances, analyze their properties, and understand their structure by examining the light they absorb or emit. This technique is widely used in fields like chemistry, astronomy, and environmental science, making it essential for scientific research and discovery.
In conclusion, both chromatography and spectroscopy are indispensable tools in modern analytical science. We have reviewed how two common cannabis potency methods, chromatography and spectroscopy, work. The two methods were evaluated using the criteria of accuracy, speed, and cost. Chromatography is accurate but can be slow and expensive to use. Spectroscopy is typically not as accurate as chromatography but is quicker with a lower cost per analysis. Because of its accuracy, chromatography should be preferred for in-laboratory use for applications such as compliance testing. Because of its speed and low cost, spectroscopy should be preferred for in-house or field testing.